Barrry Jones.
Well, Carolyn and friends, first of all, I want to begin my remarks with a disclaimer. As you pointed out, I was active as a Labor Member of Parliament. However, I'm not here tonight as a partisan, but as somebody who's been, as you said, speaking and writing about the issue of climate change since 1983, 36 long years ago, when I was Australia's Minister for Science. And I should also disclose that I have a good personal relationship with three candidates in Kooyong, and one, of course, is a very close friend, and I've had the opportunity to meet three of the other speakers who are with her tonight. So I'm not here as an advocate. It's not for a particular candidate or party, but for the science. My profound concern is that on the complex issue of climate change, global warming, we must begin with the science, then work through to the social, economic, and political implications. In my observation, if we start with the politics, then work back to the science, we invariably get it wrong. So in my role tonight as an apolitical guru, I'll attempt to set out the fundamental nature of the climate change global warming challenge. And I thought maybe the best thing to do was to raise a few issues by way of the dreaded dot points. Matter is neither created nor destroyed. Now that was something from the law of the conservation of mass, and that goes back to 1789, time of the French Revolution, and Antoine Lavoisier. He made the point that matter is neither created nor destroyed, that in other words, that coal, after burning, when it turns into CO2, but the total mass of carbon doesn't diminish. It disperses, but the total mass is still there. And it survives in the atmosphere, or really in the biosphere around us, for decades, perhaps even longer. That is, atom for atom, molecule for molecule, it simply stays around. It doesn't go away. And it's a classic illustration, I'd say, of market failure. If you buy something that you use and consume, you then have to dispose of it. In the case of burning a fossil fuel, because it disappears into the atmosphere and you can't see it except as particulate matter, it's a classic area of market failure, because you can't then say, well, I'm going to take a responsibility, I'll pay for its disposal. Only the community has the access to do that. Next, I want to talk about greenhouse gases, to define greenhouse gases. Now, water vapour is by far the largest in volume, but then there's carbon dioxide comes in next, and that has a very significant feedback loop, I mean virtually a catalytic effect with the water vapour itself, so that the water vapour really goes a long way in retaining radiant heat. That's in the thermal infrared range, and it retains it for a very long period. So you've got carbon dioxide, you've got methane, you've got nitrous oxide, alias laughing gas, but it's very significant as a greenhouse gas, and ozone. And these gases absorb and emit radiation. Now, human activity makes a very significant contribution to the production of CO2, methane, and nitrous oxide. Now, the story of the greenhouse gases is not all bad. We depend on greenhouse gases as a blanket to keep the Earth warm. Otherwise, we'll be too far away from the sun to sustain human life. Mean temperature on Earth is currently 15 degrees Celsius. Without greenhouse gases, mean temperatures would be minus 18 degrees Celsius. As I say, not enough to support life. Now, the science in this area is pretty robust. It was virtually settled in the 19th century. From Fourier in 1824, the very interesting American woman Foote in 1856, Tyndall 1859, Arrhenius 1896. So we know a good deal about the operation of greenhouse gases. The significant thing is the threat to equilibrium. I mean, over an enormously long historic period, we've been used to the idea, and we learnt it at school when we used to learn about transpiration, that there was a rough equivalence between the production of CO2 and its absorption through trees, absorption through forests, absorption through vegetation. The problem is that we've now reached the stage where the equilibrium is seriously under threat. And you don't have to get very much off the target, like walking along a tightrope. You only have to have a pretty small deviance if you're on that tightrope, and you can be in very serious trouble. Now, the annual increase of 10 gigatons of CO2, that's an annual increase of 10 gigatons, due to human activity, disturbs that equilibrium between naturally occurring production and absorption of greenhouse gases, in which oceans and forests were sinks. CO2 and some other greenhouse gases stay, as I said, in the atmosphere for decades, perhaps longer, absorbing and retaining more heat from the sun. Methane's got a shorter lifespan, but absorbs solar heat many times more effectively than CO2. And we can observe that there are massive retreats in polar ice and glaciers, acidification of the oceans, increasing numbers of extreme weather events, floods, droughts, hurricanes, and cyclones. So the medium to long-term risks seem to be disturbing. The thawing of the Siberian tundra would release vast amount of methane if it happens, far more potent as a greenhouse gas than CO2. If significant areas of the Antarctic ice shelf and Greenland were to melt, it would lead to significant sea level rise and risk the drowning of major urban coastal cities and towns. On this question of equilibrium, it's worthwhile pointing out that in the case of CFCs, chlorofluorocarbons, you remember the controversy years ago, in fact in the 1980s, when there was concern that the chlorofluorocarbons, although their proportion in the atmosphere is minuscule compared to coal, absolutely minuscule. Nevertheless, there was an agreement on both from industry and from science that those chlorofluorocarbons were having a major effect on opening up the hole in the ozone layer. And curiously, the matter passed without controversy because industry said, well, that's all right, we'll convert from CFCs to HFCs, to hydrofluorocarbons, which didn't have that effect. And so the result is there's never been a controversy so far as the role of CFC has been concerned, because the industry said, right, we'll make the adaptation. But in the case of, say, the producers of coal and oil, fossil fuels generally, it's not as if they say, well, we've got an alternative product that we can turn to. We've got to look at the issue of climate change in the context of population. Now, the world population currently is just on 7.7 billion in very big cities, which are dependent on increasing, indeed exponentially increasing use of fossil fuels. The projection for population in 2050 is 9.8 billion. Now, next, there's what I've called the 7 C words. There are 7 C words that are absolutely critical to our discussion about climate change and how it operates. And those words are coal, cities, cars, cement, consumption, conservation, contraception. Oh, and I've left one out, cows. No, if you added it, of course, 1, 2, 3, 4, 5, 6, 7, 8. Scrub that, make it 8 C words. Cow, because cows, of course, are prodigious producers of methane. Now, each of these factors, even contraception, determines population the rates of population increase through natural increase. That's an important factor. Our cities tend to be, person for person, far more prodigal in the consumption of fossil fuels than, say, rural areas are, although the rural areas and the smaller towns do make their own specialist contribution, particularly with where methane is concerned. Now, all these factors are central to our lifestyle, and each is interrelated and dependent on high and rising levels of consumption, and they contribute to what are quite often called wicked problems, in which there'll be victims if we take action, and there'll be more victims if we don't take action. But it's not as if you say, well, there's an easy formula, and we can simply apply it, and everyone will agree without difficulty. So we have to evaluate risk prudentially, even where outcomes are uncertain, as we do all the time in our lives with insurance, creating fire brigades, life-saving services, emergency services, and the like. Human factors. The human factors most contributing to climate change is that burning fuel combines with oxygen in the atmosphere, the biosphere in particular. 1 tonne of coal produces 3.67 tonnes of CO2. Petrol, 1 tonne of petrol produces 2.2 tonnes of CO2. Natural gas, methane, more complicated chemical reaction, 1 tonne of natural gas produces 1.9 tonnes of CO2. So to repeat, use of fossil fuels in transport, massive land clearing, increased population, longevity, urbanisation, and per capita resource use are also major contributors. And the abundance and cheapness of coal, of course, exacerbates the problem. And then I hope it'll be up there on the screen. Maybe, oh yes, there you are. It's simply that if you look at the rising temperatures, you can see, of course, that there's a difference between summer and winter, difference between the seasons. So it's not as if it's a single linear shape. It goes up and down, but you can see where the trend line in red goes up. And the very last chart that I have, and I hope that'll work out. You may find some difficulty in reading that, but that's really an indication about CO2 levels, that there's a baseline there and it would go up and down. This is over a very long period. And then in recent decades, you've had an exponential increase. So these are the issues that you have to think about. This is where you'd have to say that our major scientific organisations, our universities and so on, both here and over the worldwide, I'd say I wouldn't use the word consensus. I'd say there's a convergence of the examination of data, and they reach a similar conclusion. In other words, that we have to act prudentially. We might be lucky, like an idiot winning the lottery, but on the other hand, we have to recognise that the risk is serious, and we have to take prudential steps to minimise the impact. Thank you.